Based on result obtained, untreated soil has a plastic index of 5.89 and is classified as seal of low plasticity, while modified soil has plastic index of 2.33 and is classified as seal of intermediate plasticity. Untreated soil has optimum moisture content of 38% and maximum soil density of 1.44 gram centimeter cube, while modified soil has OMC of 37% and MDD of 1.4 gram per centimeter cube. Lower optimum moisture content indicates that the modified soil require less water to achieve maximum compaction. Higher maximum dry density show that the modified soil can be compacted to a denser state than untreated soil. Lastly, the addition of crushed clay bricks improve the compaction characteristic of soil, making it more suitable for construction application.
The purpose of this project was to investigate the engineering properties of clay soil before and after it was modified with our sustainable material. To achieve this, we conducted the ultimate limit test and the standard product test on both untreated and modified sample. By comparing the test result, we were able to evaluate how the sustainable material affected the soil plasticity and compaction characteristic. This project is important because it helps determine whether the modified soil is suitable for construction application. Understanding the soil behavior allows engineers to make better decisions when designing foundation, embankment, and other civil engineering structure. In addition, incorporating sustainable material into soil improvement promotes waste utilization, reduce environmental impact, and support more sustainable construction practice. There are several factors that can affect the accuracy of attribute limit test and standard product test. During the attribute limit test, the amount of water added, the mixing process, and the operated technique when using the Casa Grande apparatus or rolling the soil thread can influence the result. For the standard proctor test, factors such as the moisture content, the number of rammer blow, uniform compaction of each layer, and proper sample preparation are important. Any inconsistency in this procedure may produce different test results.
Throughout the laboratory work, several safety precautions were followed to ensure a safety working environment. Personal protective equipment, including laboratory jacket, safety shoes, and gloves, was worn when handling soil samples and equipment. Care was taken when operating the Casa Grande apparatus and the standard proctor rammer to avoid hand injuries. Hot measure cans were handled with tongs or heat-resistant gloves when removed from the oven. In addition, the work area was kept clean and dry to prevent slips, trips, and contamination of the soil samples. In conclusion, this project successfully evaluated the effect of crushed clay brick on the engineering properties of clay soil using the attribute limit test and the standard proctor test. By comparing the untreated and modified soil samples, the differences in plasticity and compaction characteristics were observed. The modified soil achieved a higher maximum dry density and a lower optimum moisture content, indicating improved compaction performance. These findings suggest that incorporating crushed clay brick can enhance the engineering behavior of clay soil and improve its suitability for construction application. In addition, the use of recycled clay brick supports sustainable construction by promoting the reuse of waste materials and reducing environmental impact. Overall, this project demonstrates that sustainable materials have the potential to improve soil performance while contributing to more environmentally responsible engineering practice.
In our opinion, this project provides several advantages, especially in understanding how sustainable material can be used to improve soil properties. Through this study, we are able to evaluate the effectiveness of crushed clay brick as a soil stabilization material and observe its impact on the engineering behavior of the soil.
One of the main advantages is the reduction of construction waste by reusing discarded clay bricks, which help to minimize environmental impacts and support sustainable construction practices. Besides that, improving the compaction characteristic of soil can contribute to better soil performance and potentially reduce problems related to weak soil condition at construction site.
This project also provides valuable knowledge on the application of the waste material in civil engineering, showing that materials which are usually considered waste can be transformed into useful resource. Overall, this study highlights the importance of exploring alternative and sustainable solutions to improve construction efficiency while protecting the environment.